I will briefly introduce you one question that arises a lot. That is about sometimes if it's the first time that you use this kind of particle system, sometimes you guess why I put this instruction and I don't have the behavior that I expect. And I will just show you in a very simple way in Houdini before, and then we jump into Unreal, the key concept of a particle system. So basically, each particle system can, for example, have a sphere and generate inside this sphere, let's say PDB from polygon, for example. It can generate like I don't know, 5, let's say 5 point. Stop, relax iteration. So basically we have our 5 point. And what we can do, it's not necessary in Unreal, but what we can do in a particle system is, for example, set an ID. So I can recognize ID num. So I can recognize all my particles. So basically my particle born with a position inside an ID. So after that, attribute, and here we can say set position. Basically this, I will encapsulate all this stuff. Okay, this we can say is the spawn state. Actually nothing is happening, but we are defining the particles. You can see we have our particles in the system. We have spawned them inside a sphere, and they have some attributes. We can also say, for example, let's use a point velocity node. I will call it exactly as Niagara at velocity, and I can say, okay, just go y3. We can display velocity. Let's add IV, and you can see now I have particles with a velocity, but nothing happened. So our spawn state basically happened once at the beginning. It's created, and we set up our particle. So we have this state. Spawn. Once we spawned the particle, so we create at the first frame the particle, we just enter the solver. So basically, I'm sorry that I have the pen, so sometimes I enter the so-called update. In the update, I say point Lango. I update, for example, our velocity. So our v at p will be plus equal to our v at v. Update velocity is our module in this case. So I can say, for example, it would be 0.1. And you can see that our particle will move through time. Our particle will have another attribute that is, for example, life. And we can say that life is random and will be between we will think in frame for now. It should be better to think in seconds. Niagara thinks in seconds, but let's, for simplicity, think in frames. So we will say that will last between 2 seconds, 48 frame, and or we can say, okay, for example, I at frame, and life should be a float. I at frame will be 24 in this case. We can say f frame. So we will have a random ptnam between 2 per frame. Sorry, let's do float frame rate fps. Let's say 2 per fps, so between 2 seconds and 4 seconds. Run. Why complain? Okay. Okay, so basically we can check, and the life is in frame. So basically we can and also it depends from the solver how much is the substeps in the solver, but now for simplicity let's think is 1. So I will say rint and I say thif mean second life, and this will be float mean life and float max life thif max second life. Okay, and we say mean life and we say max life between 2 and 5. This is our life. So basically if we check, we have our life, and here we say I at life. We can say frame. If I at life is less than 0, remove point geoself ptnam. And you can see sorry, minus, no, okay. Okay, no, we can say if I life is higher than frame, just remove the point. If at frame is larger than I life which is the name life if at frame is larger. Okay, and you will see that my particle will die along the life. So basically this is my update. So, and in the end, you can have like that event. So probably you would ask why we did all this stuff. This is because I would like to make you feel comfortable with the actual situation of a particle system. So if we jump inside Unreal, we just create a new folder, particle system, and here we create a new emitter, a new system just to test it. Let's create fountain. We drag it and just recreate exactly the same of Houdini, and you will see that we have exactly the spawn, the update. So let's get rid of spawn rate, let's get rid of all this module. Let's get rid of velocity cone, drag, scale color. So basically this is the core module. We need a spawn. So basically we need something that does what we did here. Find a location, and in this case it's scatter 4 points, and the 4 points are in the location. One key concept is how much we do this operation. In this case, it can be seen this particle system is the so-called spawn burst, because we created once and then stop. But to recreate this, we can say spawn burst and we say 4. So basically you can see that now 4 particles are created. How much our particle lives? Let's check. Between 2 and 5 seconds. So we just go here and we say emitter initialized particle basically is the same of our module here, set attribute. We can call it initialize particle, and here we say 2 to 5, and our particle will live between 2 and 5. You can see one thing. You can see that now I have 5 particles, 4 particles to be sincere. Yeah, 4 particles. And but then becomes 8 because their life will exceed the loop duration of our emitter. So basically is infinite, and every 2 seconds is spawn 4 particles. So basically we can say once. And it's the same behavior of Houdini. You can see particle die. That's good. So we want them the same things. We want them to go up in our y-axis. You know that Unreal have different axes, but in initialize particle we just say add velocity, And here we say, let's go to Z1. Let's say Unreal works in centimeters, so it's a little bit different. And our particle go up. So basically we added the velocity, and there is actually a node that takes in account how to solve velocity. It's quite complex because it solves force and velocity, but we can also get rid of it. For example, it will throws out an error, but we can say scratch pad module, and we can say we can create it by ourselves. And we can say, for example, as in Houdini, the same, our particle position and our velocity. Sorry, wrong. Remove pin, position. We add. I like to specify the vector, so basically we'll add both, and we update the position of our particle. Be sure that it's particle position, not engine owner position. And this little scratch module, we want to rename it, and we say update position. Basically here complains, and we can actually dismiss the issue because it works in the same exact way, because we just made the calculation by ourselves. This is also to introduce you how you can go in depth in the system and write your own system. You can see it works. And what we lack, we need the original position. So basically we have the spawn. If here, I will show you one thing. Let's get rid of it for now, and you see nothing happened. So let's say that at velocity also add many stuff. We can we can also do like this: set new or existing parameter directly, velocity, and we say 15, and it will not complain anymore because most of the modules just use a lot of instruction to take in account many things. But let's do it really from scratch, and we have our system, and I will show you one thing. Okay, if I do sphere location, and basically sphere location create a sphere and position particle, you can see that in update, every time particle change their position. Or, better to say, you see, I updated the position, but they do not move. And this is interesting because I updated, and if I get rid of it, they will start. And because we are doing in update, we put them inside the sphere, and this sphere continuously override the position. So if I do this, for example, you will see that it will not move at all, even if I switch them. If I put them in spawn, you will see that actually it works. Because I set, when I initialize exactly as in Houdini, I set the position. I show you another case in which can be, let's let's make the location, but let's make 25 really small. And I want the particle to be random, no, sorry, to be non-uniform. So basically I want them to be stretched like 50. And I want them to be aligned with velocity, so we don't have the movement of particles. So one common thing is, for example, sprite rotation rate. And it's okay. We can say, okay, just rotate by 50. And they should actually rotate. Okay, you see that they rotate. Let's say 1000. Even more. Okay, they rotate. You can see that they rotate in the same axis. But maybe I want a random range. So let's say minus 1000, 1000, and here they work good. But let's change this. You will see that they work in a strange way. They start to flicker, because in this case we have the evaluation type every frame. So every single frame, this rotation rate will calculate a random number. So basically each frame they change the rotation rate. So this spawn number, this evaluation, if you say spawn only, basically it's spawn and it works because they fix these things. Another way is I can create, for example, in my particle attributes, a float. So basically I have attributes that works per particle. Or another example is scale particle, scale sprite size, and I can say float. And if I say random range float by 0.25 and 2. Okay, they add, because before in previous version you had like per frame, and you can see they flicker. So what you could do before was, and maybe is useful in general for other stuff, is to set a new parameter that can be, let's say, sprite scale, for example. Of course, for scale, you have modules that does that, but maybe you have some other attributes that you use in Scratch module, or maybe you want to override motion blur or something like that. So basically, you can just set random here, like 0.25 and 3, let's say. We want the sphere location to be 85. And we take this value and we just say sprite scale factor vector 2D from float sprite scale. And here you can see that now they simply scale at the beginning. So in this way, you created a value in spawn. So all this to make you to be sure about the state. The state are emitter settings. So basically this Niagara create our emitter. We have some properties, is local space. Determinism is our random, pseudo-random number should be the same every time. So basically, if we work with a system that should always look the same, this is the way to go. We want to be in CPU or GPU simulation. If we are in CPU, we can fix the bound for the system, we can have different scalability according to the setup of our game and so on. So basically we set up the emitter, the general emitter, we spawn the emitter, so you have some element that you can spawn together with the emitter. We have the update, so basically we should this is interesting, this is the update of the emitter. So basically our emitter start, it updates, and during its update it spawn stuff. In this case it spawn one single burst of particle. If our emitter, why it's an update? Because our emitter, for example, will be infinite. So basically it will keep spawning stuff, and every like 2 seconds it will spawn. Let's say, for example, like this, it will spawn every time, every 2 seconds, it will spawn back again stuff. Infinite. You see, every 2 seconds it spawn stuff. Then we have the particle life, that we have the spawn, we initialize particle elements, and here this is calculated once per particle life. So basically particles are spawned, we calculate this once, and on the tick for the particle we calculate that. And after this part is basically the simulation of the particle, we need to render, and so we go to the render, and the render can be sprite, can be a ribbon, can be a mesh, can be a light. So basically we have this step. We have a cycle for the emitter, we have a cycle for particle, and in the end we have an end cycle that is to render actually our system. So I hope it's a little bit more clear how the emitter works, how the particle system works, and be really careful to understand when you do some operation where actually you